All right, everybody, I think we're going to go ahead and get started. My name is Chris Reisner. I'm a technical evangelist at Microsoft. I work on the Windows Azure team, so I'm actually going to be talking to you today about building Windows Store apps in conjunction with Windows Azure. Specifically, I'm going to be talking about Windows Azure Mobile Services, which is a fairly new thing we just released and should make building Windows Store apps a little bit more exciting for you. So let's go ahead and get started. So first of all, what is Windows Azure Mobile Services? Essentially, it's a backend as a service, which means that you basically turn the service on and you get a backend for your mobile applications. So you're going to get things like data storage out of this. So you need a place to put that data, somewhere where you can retrieve it. Mobile Services is going to give you that. In addition, a way to do push notifications. I think either earlier today or yesterday in one of the other sessions, you saw how to do push notifications from a web role or something along those lines. I'm going to show you a pretty simple way to do that, which is done from mobile services. So authentication, and when you're making a mobile application and you've got a backend for it, there's really a couple different kinds of authentication you need to worry about. One is getting your users so that they can authenticate inside your app, so you know who they are and make sure they're the person that should be seeing the data they are. And then in addition to that, how to actually secure your backend. Also, some server-side logic. So we can't just figure out exactly what you might want to build and pre-build everything for you. So you want to have the capability to do some server-side stuff on your own to control what's going on. Diagnostics. So the ability to look into what's going on with your mobile service and indeed, in fact, your application as well. Same thing with logging there, so the ability to actually log information as it comes across. And then lastly, scaling. If you build a Windows Store application and it becomes super popular and super big, you want to make sure that you're not going to have to do any work to stay up and available along with that application. So the first thing I'm going to do is actually walk you through a demo of getting a mobile service up and running and then working with a mobile or a Windows 8 application that will connect to it. So this right here is the Windows Azure portal. It's HTML5 and JavaScript, so if you are connecting to it from something that's not a Windows device, it's still going to look and function really well. Inside here, we've got access to a bunch of different things that Windows Azure gives you. Today, we're obviously going to look at mobile services, so let's go ahead and create one right now. So we'll just name this iOS event, and we'll choose to create a new database. So the data storage that you get out of mobile services is built using a SQL database. Now, that being said, you're not going to have to do a lot of SQL management that only DBAs know how to do. So I'm going to use a pre-existing server. It would be just as easy, though, for me to actually spin up another one if I wanted to. So we're going to let that create, and it's actually going to take a minute or less than a minute, but a few seconds to do. The reason for that is that when you go ahead and click create, it's actually spinning up a new database in the back end. It would be spinning up a server I'd chosen to. Then it's provisioning and creating a whole bunch of endpoints for our mobile service. A bunch of stuff that you don't have to worry about coding, testing, and deploying yourself. It's just going to give you out of the box. Okay, so that one's ready to go. So now we can actually go into it. First thing you're going to see here is the Quick Start screen. As you can see at the top here, we can choose our platform from Windows Store, Windows Phone 8, and iOS. Obviously, today we're talking about Windows Store stuff, but everything I'm going to show you is very easy to accomplish from either Windows Store, Windows Phone 8, or iOS. And everything I'm doing can be done on any of those platforms if you wanted to. So we'll go over to Windows Store. When I do that, you see here we have two options. We can create a new Windows Store app, or we can connect to an existing Windows Store app. If we already had a Windows app that we had built, we could go in here and see the steps for adding mobile service support into our application. You download and install the SDK, add it into your application, and then here's how you do some stuff. We're going to skip that and go into create a new Windows Store app. What this does is it gives you a quick start application that resembles a simple to-do list that's pre-built for you. You basically get it, and it already has some functionality in it, and then we're going to take that and we're going to expand it today. So you click that and you get the steps. First of all, you install Visual Studio Express, then install the Mobile Services SDK, then create a table. Now, when I said that we get, we're backed by a SQL database, but we don't really have to worry about anything, there's kind of one step that we do have to do, and that's tell mobile services what the names of the tables we're going to use are. That's really the only step that we have to do for our tables. So we're going to do this right here, and it's just going to quickly create a to-do item table for me so I don't have to do it myself. Down here, we could choose between writing a C# Windows Store application and a JavaScript. I'm a little bit better at C#, so we're going to look at that today. So we'll download this. Extract that. And we'll open up and run it. Now, we'll take a look at the code in a minute, but the first thing we're going to do is actually run it and kind of see how it works or what it looks like. Again, this application that we get is a simplified to-do list. We can add items to it, and we can mark them complete. So we're going to go to San Francisco for this event. And I'm hungry, so we got to eat some lunch. And of course, we're going to talk about mobile services. So clearly, I'm already here in San Francisco, so we're going to go ahead and mark that as complete. So let's go back to our portal. We're going to go back to the top, and we see there's a data tab here that we're going to go into. Now, when we go to this data tab, we get a list of all the tables that are associated with our mobile service. If we click on this one, we can see that we have 3 different columns right now. There's an ID column. Well, there will be shortly. All right, there we go. So there's an ID column, there's a text column, and a complete column. Now what happened there was I sent over data to my mobile service for each of those to-do items, and basically I sent over the text field and the complete flag. The ID is there by default because mobile services needs a unique identifier for each row in your tables. However, that text and that completed column, I never actually told anything. I never went to the SQL database and said I need these columns. I never said that in my mobile service. It's because mobile services uses something called dynamic schematization. So when I send data over the wire, it inspects that data and says, I don't have a column for text, I'm going to create a new one, and it looks like this is a string, so that's how I'm going to save it. I don't have a bit field or a boolean for complete, so I'm going to create one, and that's the type that it's going to be. Again, ID is there by default. We don't worry about it. It's just there. So let's go ahead and go back and look at the code and see exactly what's going on. First thing we look at is the references. Now in here we see there's a Windows Azure Mobile Services Managed Client. This is similar to a framework you might have in an iOS application, where it's basically a library that gives us a lot of access into mobile services functionality. Now if we go down here to the app XAML class, what we see up here is an instantiation for a mobile services client object. This object is instantiated with the URL of our mobile service that we just created, and then this was an application key, which is basically a random string of characters. If we go back over to our portal for a second, and go into the dashboard, we can go to Manage Keys right here, and we see this application key, that's the key that we're passing in. Both the application key and the master key are used for some sort of authentication that I'll get into a little later. Just remember that when we instantiate our mobile service client in our app, we specify that application key. Now if we go over to the main page, which is the only functional part of our application here, first thing we see is we have a to-do item class. This is actually the class that we use to create all our to-do items, read them back from the server, or rather, it's the object we use to represent all of our to-do items. We're going to use that several times throughout the data stuff we're going to do below. Now, a bit larger, yes I can. 1 second. Is that going to work for you? Better? Perfect, thank you. Okay, so we use that several times while we're doing the data stuff. Now, down inside the main page class, we have this mobile service collection view, which is basically our local collection of all the to-do items. And then we have this iMobile service table, which is the type to-do item. So this to-do table is what we actually use to talk to mobile services and handle all the operations with our data. Inside this insert to-do item, we'll see this method takes in a to-do item object and then just passes it into the to-do item table's insert async method. So we're taking that class and pass it in. Now behind the scenes, stuff that we don't actually have to worry about, but it's going to serialize that to JSON and send that data over the wire. So all of the mobile services, the data endpoints, they're all JSON based. But again, we don't have to worry about that. It's going to handle that for us. Then after we get back from that, because we're using async and await to basically say or process this, and then when you're done, continue execution, we add that to our local collection, which in turn adds it to our list view on the screen. Down here, when we actually refresh or pull down the items, we use our to-do table and we pass in a query right here, which is similar to what you might use an NS predicate for on iOS. We basically pass a query in to say, give me all the to-do items that aren't complete. Now what happens when we do this, again, behind the scenes, it's converting this over to an OData filter, which is going to mobile services. Mobile services is then taking that OData filter and converting it into SQL. All of this behind the scenes without you having to worry about doing any OData or any SQL yourself. Finally, when that's done, we set the list items item source to be those items, which will then display them on the screen. When we actually update the to-do item, we just get the to-do item passed in, and we're just calling update on our to-do table. Now, down here below, when we add a new to-do item, so we typed in our text and we hit add, we create a new instance right here and set the text property. We don't have to set the completed property because by default it's going to be set to false because a Boolean, it's, by default when it's constructed it's false. We can then call the insert, which calls the method we saw before. When we check an item or mark it complete, it's pulling that item out from the view. Since it's data bound to the object, we don't have to change the completed flag ourselves. It knows that since the box is checked, it's true. And then we call update on that. And lastly, when we actually get to the page itself, we're refreshing it. So that's basically all you really need to do in order to get really simple and easy data storage and data access in an application. So again, using SQL database as your backend with very minimal work on your end. Now that SQL database is fully accessible, and what I mean by that is that if you wanted to also deploy a website or another application, anything else really that had access to that SQL database, you can do that. It's not like it's hidden behind mobile services and mobile services is the only thing to access it. You can really do whatever you want with that. Yes? All right, so the question was, can you use a different database provider, so something like Mongo, for instance. As of right now, it's tied directly into SQL database. So there's no option to either use something like MongoDB or Windows Azure Table Storage or anything like that for right now. So dynamic schema, it's on by default. So when I create my mobile service, I don't have to tell it I want it on. It's just on. So when I send data over the wire as JSON, it's going to look at it, interpret it, create the columns it needs to. You can turn that off if you want to, which you probably would want to do before you go to production, just so you don't accidentally add some new random columns while you're testing. And then lastly, again, it's all JSON based. It's all going over to REST services. And when you use the SDK, all that serialization is done for you, so you don't have to worry about how to serialize stuff into JSON and read it back into the actual objects. All you have to do is instantiate, in this case, a to-do item class, which is one line of code, very, very simple. Now, in addition to generating a REST API whenever you create a table for that table, you get some other stuff. First of all, with that REST API, you get a very rich querying capability based off that OData I mentioned, which gets translated into SQL. You don't have to worry about it. You just get to use a link to objects to basically create a query, which, in more or less common sense terms, which will then be translated for you. In addition, when you create a table, it also generates server-side scripts that intercept each CRUD operation. So whenever you do an insert, an update, a delete, or a read, there's a script that gets fired that intercepts your command before it goes to the database or before mobile services processes it. And these are scripts that you can change to basically do a lot of different stuff that you might want to do. These scripts are powered by Node.js, so it's a minified version of Node. So if you've done Node before, you're not going to get access to all of the modules you have in Node in here, but there's quite a lot you're going to be able to do. So examples of what you might want to do is validate the data on an insert or modify a query to match something you might want to do. Both of these are things we're going to look at today. In addition, there are a lot of modules that give you extended capabilities beyond just the basic stuff you can do in JavaScript. So some of the modules you've got right here are MS SQL, which would allow you to execute custom SQL commands or even start procedures against your database if you want to. Again, that database is fully accessible, so you can put stored procedures on it. You can add different tables, different columns, whatever you want, and then use MS SQL to do essentially whatever you want in that operation. You get access to whatever the request was via the request module. You can log information using console. You get push notifications via the push module. You can access the tables that are part of your mobile service with the tables module, and then status code. So if you want to return a status code other than the normal, you can use that. In addition, there's also the capability to send emails from your scripts using a module from SendGrid, and then send text message or SMS messages using a module from Twilio. So here's an example of using the MS SQL module to call a custom query inside your script. So the first thing we're going to do now is we're going to take a look at adding some server-side logic, and I'm just going to do data validation. Specifically, what I want to do is say that I don't want to be able to save to-do items that are less than 5 characters, because that just doesn't make any sense to me. So we'll go back to the portal, and we're going to go into the Data tab. When we look at the to-do items table, we see there's a script tab up here next to Browse. If we click on that, so we've got our operation, which is insert, and it's got this little function here, this JavaScript function, and all it's doing is executing that request. If you look at any of the other ones, so insert, update, delete, and read, they're all going to be pretty much the same. Right now, all they're going to do is request.execute. If you look at what's coming into this, you have an item, which is the data for the object that's getting sent over to be inserted, user, which we're going to look a little bit closer at in a few minutes, and then request. The request is the actual request into the server. So we can change this right here, and we're going to validate the length of our text property. All right, so basically what I've said is if the text.length property is less than 5 characters, I want to respond with, the bad request status code, which is going to be, obviously not the 200 or 201 we'd expect, and then the message, your to-do item must be at least 5 characters. All right, so that should be saved now. Yep, that's saved. So let's go back and run our application. And we'll just type in ABC, or close enough. All right, so we got an error. Our application crashed, which is good because as the application developer, I should decide what I want to do in this situation. I would probably want to put some message up and show the user, hey, your to-do item needs to be at least 5 characters. But that's up to me, and now I know I need to do that. But we can see right here that we do get that error message back. So let's just add another item just to make sure that I didn't, completely break things. All right, so now everything seems to work just fine. So again, that's a relatively simple example, but something we could do inside of a server-side script. So I'm pretty sure you guys saw push notifications already. I'm going to walk you through them really quickly again, how they work, and then show you a really simple way to do them from inside mobile services, or through mobile services rather. So first thing that happens is the Windows 8 app requests a channel URI from the notification client platform. It gets this channel URI back, and then we're going to send it over to mobile services and basically save it in our mobile services database. Then when we're ready, our mobile service can then authenticate and send a push notification using that channel URI to the Windows push notification service. That can then talk to the notification client platform, which will deliver that notification to your application. So let's look at setting that up right now. So the first thing I'm going to do is actually associate my application with an app I put up in this, or an app I registered in the store yesterday. So that did some fun stuff, which I think you guys have already seen, like created a certificate and basically tied that to what's in the store. Now the next thing I need to do is go into the portal and put in some information that also identifies my app in the store to my mobile service. So if we go back in here and we go to the Push tab, we see that for Windows application credentials, we need to put in a client secret and a package SID. So I've got those from the application, or from the store right here, that I'm just going to paste in. And I'm going to save. And also, as you can see down beneath there, there's options if we were going to do push notifications through Apple. It's right there. We just need to set some stuff up. All right, so the next thing I'm going to do is create another class by my to-do item that's just going to be used to be for my channel, for sending a channel over across the wire. So all it's going to use is just an ID, just like we have for to-do item, and then the channel URI. Now I'm going to change the onLaunch method to be asynchronous because I need to actually save information to mobile services inside of it, and I want it to await. So now at the bottom of onLaunched, I'm going to do this, which basically means I'm going to use the push notification channel manager to request a channel URI for my application. When I get that back, I'm then going to use mobile services I'm going to get the table for channel, and I'm going to insert our channel URI into into our database. So I believe that's a couple more things I need to do on the server side. So let's go into the data tab, and we're going to create a new table named channel. Now I didn't show you this before when I created the to-do item table, but we've got some operations for authentication on table operations. I'll talk a little bit more about that in just a few minutes. For now, I'm going to leave that as is though. So I'll go into the script for channel, and I'm going to drop this script in right here. Basically what this script is going to do is it's going to pull out the channel table. It's then going to try and look for the URI that I'm passing in inside the table. If it finds it, it's just going to respond and say, hey, I've already got this channel, it already exists. If not, it's going to execute the request and save it. Now we'll go back to the to-do item script, and we're going to get rid of that validation and change things up a little bit. So instead of doing that validation on the length, what we're going to do instead is we're going to execute our request to save the to-do item, and then we've got a success error block right here. So if saving that was an error, we're just going to respond to the calling application with a 500 response code, and that it was an error. If it was success, we respond to the application just like normal, and basically this tells our application, hey, don't wait for a response from mobile services anymore, we're done, and then we're going to keep executing stuff inside our script. Specifically, we're going to call the send notification method. And this method down here gets the channel table, reads each record in the channel table, and for each record, it's going to push out a toast notification with the item text that was saved. So that's saved, and we should be able to now run our application. So we're going to test push. All right, so we got our push notification. It showed up. We're great. Now, obviously, this may not be ideal because we're going to send a push notification to any channel URI that's in that table, and really, I don't want everyone to know what my to-do items are. So that's something we're going to look at next. So we solved that problem with authentication. Now there's two kinds of authentication you get with mobile services. The first, and arguably most important, is user authentication. You need some way of identifying your users and making them have an easy way of getting access to your application. So with mobile services, you get very easy authentication with Facebook, Google, Microsoft accounts, and Twitter. You saw a little bit of authentication earlier today using the Live SDK. We're going to do something similar in just a few minutes so you can see it done again. In addition to that user authentication, you also get authentication for each operation on a table. Now, a minute ago when I created that channel table, we saw that there were 4 drop-downs for the different operations on that table. Now, by default, it was set to anybody with the application key, which means that any request to my API that has the application key, it's allowed in. Now, if you recall, when I created my MS client at when the application starts, I pass in the URL of our mobile service and the application key. When I do that, it's sending that application key over for every request, which is why it's able to get through the setting with anybody with the application key. Alternatively, I could set it to everyone, and then as long as I knew what my API path was, anything could access it. They don't need the application key. However, if I really want to be secure, I want to make it so only authenticated users can access it. So that's the next option, and we're going to look at seeing how to actually implement today. Lastly, however, you can also do only scripts and admins. When you do that, no request to your applications, to that table's operation will work unless it has the other key that we saw earlier when I looked at managed keys, which is the master key. That's something you probably wouldn't want to distribute in your application just in case somebody was able to disassemble your source code, something along those lines. So basically, the master key gives you access to everything. Also, then scripts can also affect that table. in addition, inside of your scripts, you can actually access the user's level and the user ID in case you wanted to do any special logic off of that. So we're going to go ahead and add authentication with Windows Live now. So the first thing I'm going to do is in the portal, I'm going to go over to the Identity tab. And under the Microsoft account settings, you see that we already have the client secret because that's the same secret we have for push notifications. All we have to do here is put in the client ID. Down here, we also see the authentication settings for all the other types of types of providers, I should say. All right, now while that's done. Before I do anything else, I'm actually going to change the authentication type on my to-do item table so we can see what happens if I don't actually have permission to perform the operation I want to do. So again, it's anybody with the application key right now. I'm going to change this to only authenticated users. So what should happen is I should try and actually pull my to-do items, and it shouldn't work because I'm not sending over a user right now. All right, great. So we're unauthorized. Again, this is going to crash my application, which isn't really ideal for users, but then again, we shouldn't be designing our application so it would really crash in this manner. And this is my signal to me that I need to develop around this and make it actually work correctly. So let's go ahead and kill that. So I'm going to go back into my application, and I'm going to add a new reference. And I'm going to add the reference to the Live SDK that we saw earlier. Now, we're going to do authentication the same way you saw it earlier today, which is using the Live SDK. However, mobile service is going to give you something that doesn't require you to use the Live SDK if you want, and I'll talk about that in a minute. So, first thing I'm going to do is in my onNavigated to method, I'm going to call a new method called authenticate. Only I'm not going to do it like that. So this method is basically going to, again, use the Live SDK. And this code right here is pretty much the same as what we saw earlier in Jaime's session. So the first thing we do is we're actually going to force them to log out, and this specifically for testing, just so we can see how the login process works. Normally, you probably wouldn't want your user to log in every time, so we wouldn't do this. When that's done, we log them in. We get a token back from that login through the Live SDK, and right here, we're actually going to also call login async with that token to mobile services. This is so that our user is registered with mobile services as well. If we didn't do that, we wouldn't have a valid login object, or rather valid user object, to send to mobile services. When that's done, we're just going to show something to the user that says, hey, you're logged in. What's important, though, here is that we can log in through the Live SDK and then call a separate method through mobile services to basically authenticate the user to mobile services. Now, we don't have to use the Live SDK, and in fact, if you were going to authenticate through any of the other providers, you clearly wouldn't use the Live SDK to authenticate with Twitter or something like that. Mobile services has basically a single line of awaitable code that you then call instead to authenticate through any provider you want, and that'll pop up the familiar OAuth web login display. And it's all basically done inside the mobile services SDK. All you have to do is call that one method. For now, though, let's go ahead and run this. So just like Jaime showed you earlier, I didn't have to log in because I'm logged in to my account on this machine. So it's just saying welcome. If I didn't have that code in there to pop this up, it would just I'd already be in the app. It wouldn't I wouldn't see it. It would just show me that I'm there. So great, I'm in the app now. However, all these to-do items are still shared. There's no concept of what's mine and what's yours. It's just everything's open. So what we'll do next is actually fix that. So we're going to go into our portal and add some more advanced scripting in. So inside the to items insert, what we really want to do is when we save an item, we want to tie that item to our actual user. Thankfully, when we do authenticate through mobile services, we always send a user object across with every request. So we have this user request or user object as a variable. So in here, before we actually process the request, we're going to add that to the item that gets inserted. So what I'm saying right here is take the item that we're going to insert, add a new property named user ID, and set it to the user ID that's as part of the user that's getting sent into this method. So we'll save that. Let's go back to our service. and we'll save the user ID. Now if we go back here and go to Browse, so we see now, we have a new user ID column. We didn't have to tell it, it just added that because it saw it was new data coming across the wire. And we see that we have this Microsoft account and then this unique number that's identifying my user. So now we just need to limit the data that's coming back. Now there's two ways we can do this. We can do it on the client side, and basically what we can do is in that where clause that we said, where completed is equal to false, we could also say and the user ID is equal to the user ID. However, as with any mobile application development, you never want to fully trust what's coming from the client. So what we'd rather do is actually limit our results on the server side where we know and can absolutely control what's going to happen. So we'll go into the to-do-item scripts and go to the read method. And in here, what we're going to do is dynamically add something to the query. So what we're basically saying is whatever the query that gets sent in, I want to add this where clause that says the user ID is equal to the user ID that's passed in by mobile services. So now when we save this, it takes a second. All right, good. So now that's saved, and we'll go back into our application, and we'll hit refresh, and we should see one single item, the only item that's saved with my user ID. So now I've got easy authentication through a provider, and I've got an easy way of then limiting my data to that user. Question? Can you speak up? I'm sorry, I really can't hear you. Either one? Yeah, so the question is, if you want to do multiple different authentication providers, what do you do? So essentially in that identity tab in mobile services, you'd fill in all the providers you want there, and as soon as you turn each one on, you have the ability to call that from your application. And you would just need to give them a UI to say, hey, I want to authenticate through my Microsoft account or my Facebook account or my Google account. So all you have to do is present them some way of choosing which way they want to authenticate, and then just call that provider. So again, if you don't use the Live SDK, it's a single line of code that you call to mobile service and say, authenticate with this provider. So you would just have a case statement and say, oh, they clicked Facebook, so call the line to authenticate to Facebook. And no matter what you call, it's going to pop up an OAuth UI for them to log in through. Does that answer your question?
Well, I was thinking of having them both,
Either or? Right, yeah, so that's what I'm saying. I mean, you present them a UI where they choose what they want to do, and then they can choose which system they want to authenticate through. You just make whatever call whichever one line to mobile services, whether it's the call to Google or the call to Microsoft account login. Okay, so yes, 1 second, she's going to bring the mic to you.
Do you have any provision for roles and profiles?
One more time?
Roles and permissions, roles and profiles.
So there's nothing right now built in for doing role management or profiles. That's something you could do yourself by just creating a user table, and you'd have to build the management yourself right now. There's no built-in providers for you to use today. So moving on to diagnostics, logging, and scaling. For diagnostics, it gives you insight into how is my mobile service being used, how many API calls, the CPU time, and the data out. And then for logging, in addition to any calls to your scripts that result in errors will automatically get logged. However, you can additionally put in console statements yourself to log extra things. And then, as with anything else with Windows Azure, you've got the ability to scale out and scale up. So initially when you create a mobile service, it's free, and it's on a shared virtual machine. You can scale up from a shared virtual machine to a reserved small instance virtual machine that you're the only mobile service running on, and you can also scale up the number of virtual machines you have running your mobile service. So when your app becomes huge, all you have to do is toggle a button and then take a slider and slide it to the right, and you're instantly increasing the number of servers running your mobile service for you. And then as far as storage goes, You can scale out your database as far as the size goes, and you can use a single database for your mobile service since a database can support multiple mobile services, or you can use a dedicated server for your database as well. So let's look at a few of those options right now. So inside the portal, if we go to the dashboard, we get this fun little graph that shows us the usage of our mobile service. And each of these corresponds to either CPU time, data out, or memory usage. You also get these bar charts that show you the usage of this mobile service and then kind of the usage of all the mobile services in your subscription. If we go over to scaling, this is where we can choose to go from shared over to reserved. Shared instances are free, reserved are not. So when you do that, it's going to say, hey, are you sure this is going to cost you money so you don't get charged unknowingly? And then once you do go to reserve, that's when you can actually up the number of instances you got running really easily. And then down here in the database, you can change the maximum size and go from web to business, which has an even a larger size gap. Then over here in logs, this is where we get information about anything that might be going wrong or happening in our application. Now, these are logs. Since I actually had a mobile service with the exact same name earlier, and I was, causing errors with it, we've got errors down here. I didn't actually have any errors on my mobile service this time, but I did log when I did push notifications, which is what you see up here. That is not my computer. Oh. All right. Well, apparently, let me try redoing that because I don't think anybody wants to see those horrible colors. And sorry, guys. It's all right. Okay. That works. I can work with that. Okay. I'll work with that. I'll make it work. All right. Well, we're going to have some very interesting colors for the last few minutes of the presentation. Oh, wait. Maybe. I think we got it. All right. You thought you were going to have fun colors. Sorry to disappoint. So in summary, Windows Azure Mobile Service is a backend as a service. Super easy to spin up. Super easy to get running. Takes the pain and trouble of having to code, test, and deploy your own backend just out of your hands. With it, you're getting data storage, which is powered off a SQL database. You get push notifications, and that's again across all the platforms, or all the different types rather for Windows Store apps. You get authentication, both user authentication through several providers and authentication options on the server side. You get server-side logic, so whenever you want to do some custom stuff, you can handle that using the server-side scripts. Diagnostics to see into the goings-ons of your mobile service. Logging to get more information about what's going on or any errors. And then scaling, so there we go, scaling. So when your application goes huge, your mobile service can move right along with it. So to get started with mobile services, just go to windowsazure.com and sign up for free. There's a free 3-month trial, and then in addition to that, while mobile services are in preview mode, they're free just in general, and you can get up to 10 of those for free. If you go to windowsazure.com/mobile, basically everything I showed you today, there's walkthroughs on how to do that for Windows Store apps, Windows Phone 8 apps, and iOS apps. So everything you saw can be done on all 3 of those platforms, and those tutorials on windowsazure.com/mobile will walk you through everything. There's a mobile services forum that you can get to from there, which will should help answer any questions you might have. There's a feedback email address if you have thoughts, concerns, or questions. And then both myself, Chris Reisner, and then Cloud Nick, another guy on my team, we're both pretty dedicated to working with mobile services, and we're on Twitter, and we'd be happy to either hear about what you're doing with mobile services or help you out with your Windows Store apps. Lastly, this and a lot of other stuff is part of the Windows Azure Training Kit, which you can download for free online as well. And that's all I've got. If anybody has any questions. Yes, sir.
So I know your focus is Azure and those services, but can you also do your own notification server if we wanted to do stuff from our existing server?
When you say, okay, so the question is, can you do your own existing server? Can you clarify, like, can
So
you?
We've got our own servers. We want to do notification. Do we have to do push notification through this stuff, or can we do? Is there a push notification we can just grab and implement, much like we can for Apple?
Oh, I mean, there's well, if you were going to do that, you probably, I mean, if you're not going to use mobile services, you probably would just want to grab the source code to implement push notifications on your own.
Yeah.
And there's a lot of libraries on GitHub that basically, like, I think, like implementation we use for Node.js. There's a Node.js implementation for doing Apple push notifications. So there's a lot of libraries on GitHub and online where you can find that stuff.
Thank you.
Yeah. Anybody else? Yes.
The to-do, you started with the stub application. You said new application. The to-do was the stub.
Yeah, exactly. So basically, when you download that Quick Start application, everything I showed you first before I started making any changes, that is built in right there. It basically has a pre-built application that it just changes out the URL and the application key, and then you're good to go.
So I noticed the URL was iOS event with Azure something.com. So that name then becomes reserved for you.
Correct. So the question was, he saw the URL. Is that URL then reserved? So yes, when you create a mobile service, basically whatever you choose for the name, it becomes the subdomain of that URL. So it's basically your mobile service.azure-mobile.net, and that becomes your URL. Yes, sir.
Is there any support for sort of controlling how much data comes down? I mean, if you run a big query and you're only interested in 3 fields out of 20.
Yep. So there's two. So the question was, is there any controls for how much data comes down, so you're not, pulling every data in the table if you don't want to? There is. There's, I think, I forget what the term. I think it's like top and skip and stuff like that. So you can do, give me this many records, skip this many records. So you can do paging. You can do all that sort of stuff. It's there. In addition to on the client side doing that, you can also specify stuff on the server side. You can, change basically the query and say I want to pull this many rows or these specific columns.
Can you also, within an individual record, say I'm only interested in these fields?
Yeah, so again, that's something you can do. I'm not sure if that's actually part of the client SDK today. I know it should be soon if it isn't, but that's something you can certainly do in the server-side script, which is basically change the result set or change what columns the query is going to pull. So yes, that is possible.
I guess related, is there offline support?
The question is if there offline support. As of today, there's no offline support. It's something we're looking into. We're just trying to figure out how best to implement it. I got time for maybe one other question.
We have a 10-minute break, so people can always come up and ask him questions. But we had to keep rolling, otherwise we won't get out of here by 4:30.
All right, well,
So if you can definitely take one more, and then anybody that can ask him questions, you got to catch a flight too. But
yeah. If you can't find me, you can always email me here. I'm always happy to help, and just reach out to me whenever.
Yep.
All right.
And end of day, he brought us a jam box from the Azure team. So when we do the raffle, I want to give him credit now because he'll be gone by then. So we'll do a raffle part of the raffles today will include a jam box that came from the Azure team. So.